Hi again, folks. Thanks for joining us. Today's video is going to be basically to extend the work we did in our previous video, which was to orchestrate the sound of a very complex sound target, which was a very slowed down starling. In order to get a more convincing solution in the acoustic space of instruments, one of the things we're going to do is return to our familiar Max environment here, and we're going to use some features that are a little bit more intermediate or advanced. Namely, we're going to be using a larger database. We're going to be using the full SOL database instead of the smaller, tiny SOL database that you might start out with. But we're also going to be using regular expressions to filter some of the playing styles from this larger database. I should say you can do a lot of these sorts of things in the standalone application as well. But for the moment, I'd like to return to the Max environment. I personally feel a little more comfortable here, and my hope is to show you different ways of doing things using the various Orchidea tools that are out there. So let me just take a moment to introduce you to the cast of characters in front of you. I've got just the beginnings of a functional patch here that we can use to run a dynamic orchestration and then add some special features to it. Those of you familiar with the older iterations of the software will recognize orchidea.solve, which I've replaced here with the newer orchidea.orchestrate. It essentially does the same thing as orchidea.solve, but its engine's been updated and it works more efficiently. And like orchidea.solve, it resolves orchestration input parameters and proposes a number of solutions to the user. Down here you see orchidea.solution.toRoll with its detuning parameter turned on. This takes a max dictionary of solutions from orchidea.orchestrate and translates them into readable notation in a Bach.roll notation editor, which I have sent a load message to. The tone division 4 ensures that we'll have quarter tone resolution here and we'll play the detuning parameters. Down here at the bottom is the orchidea.play module with 20 voices. Also, its detuning is set to on, which is basically a big poly for playing back the instrumental samples in the Bach roll. Now up top, you've got some controls for the input parameters. Over here on the right, you'll see a number of attribute objects exposing just a few of the many input parameters that we can send into orchidea.orchestrate before we trigger the orchestration. I'm using live drops here so that we can quickly and conveniently swap out databases, as in this one right here, or the target sounds, as in this one right here. We can re-trigger an orchestration anytime by just hitting the button object. And you might notice that I'm using a lot of send and receive pairs. You might ask why I'm doing this, and that's, well, basically a good habit to get into in Max anyway, but also we'll be using these paths for the database and target in more than one place. For example, we are sending this target path into two places already using one receive object. First is into the buffer so that we can store the target sound and play it back eventually down here. And then finally, we're sending it into orchidea.orchestrate to obtain our solutions. Okay, now in order to make this patch go, we're going to have to build out a couple of things that are missing together. And I have this nice little to-do list that tells us what needs to happen in what order in order to generate the solutions, play them back, and revise them. So I hope you've enjoyed the grand tour. Go ahead and make yourself at home, crack open a drink, and set yourself up with a patch like this, and we'll go ahead and continue the process of building this out together. Let's have a look at our to-do list, shall we? First, we need to turn audio on. It's been conveniently labeled for you on this trigger object. I've just turned audio on. Now I need to define the orchestra. The orchestra needs to be defined with a message up here sent into, if I unlock the patch, the middle inlet of orchidea.orchestrate. So I'm going to create a message box here and type out the name of my orchestra. And actually, before I do this, I just want to mention something. The keen observer might have noticed in the last few videos that I actually created an orchestra that was very much out of score order. I forgot to tell you that this could be revised in the standalone app. You can reorder the instruments in the right column of the window you use to define the instruments in your score. And just as we would do that in the standalone, we can type out a message that more clearly defines the score order for us. So I'm going to go ahead and type out in score order the same instrumentation that we used in the previous videos, but in the proper score order, using the syntax that the database actually uses in the file names for these instruments themselves. Okay, and I'm going to plug this box right here into the middle inlet, and this is what I'll send into orchidea.orchestrate. The next thing on my list is set the orchestration parameters, which are over here at the moment. I'm going to leave most of this as is, but I'm going to change just a couple of things. The onset threshold, I'm going to use the same values I used in the previous video. Now the next thing you see here is to filter the playing styles, but I'm just curiously going to skip over this step for now. You'll see why. We'll build step 4 together once we create the need for it. And let's move on to step 5, define the database. So, as I mentioned before, we're going to use full SOL this time, an expanded, much larger data set than tiny SOL, which we had used previously. I'm going to take the Spectrum database file and just dump it immediately in this live drop, and it says adding the DB file here. And last but not least, we need to define the target sound. So for us, the target sound is going to still be this little Starling clip. I'm going to drag and drop it as well. Now don't be so discouraged. Initially I got this error message here that said the database was not defined, but then the notifications came a little bit later. All the information has indeed been set properly. And if I run the orchestration again by hitting the button, it will calculate and do its thing. Takes a minute because it's a large search space and a big database. And here we have our first orchestration in score order. Why don't we listen to it? Excellent. Already you see a lot of different playing styles that are happening all at the same time. Pretty good orchestration with very little sparsity, a lot of instruments playing at once. However, you may have noticed there's a lot of pizzicato sounds in there, and to my ear, these sort of pizzicato and colegno type sounds don't really appeal to the type of sound world created by this particular target sound of the Starling. So how do we filter those things out? Well, now it's time to return to step 4, filtering the playing styles using regular expressions. Now to do this, I'm actually going to just create a subpatch here, and I'll call this filter styles. So now I have a little workspace here, and I'm going to just make this a bit bigger and immediately put an outlet somewhere down at the bottom and connect this to my second inlet of Orchidea.orchestrate once again. Okay, so in here I want to use another member of the Orchidea set of objects called Orchidea.db.query. I'm going to briefly color it. And I'm also going to copy in my database because it requires the path to the same database in order to query that database. Let's send the database one more time. And we can tell that database has been received by Orchidea.db.query. Okay, let's make some room here in the console. I'm going to start by sending it a message here called getItemsStyles, and I'm just going to print the results for you. Okay, we see a whole lot of playing styles contained in this database. If we want to know, for example, how many of them live in this database, we can do something like this. Okay, 188 different playing styles, we'll say, total styles in the database. We want to filter some of these styles out that we don't want, namely the pizzicato ones. So in order to accomplish that task, I'm just going to set up a little example here. I'm going to use the Regexp object for regular expressions in Max, and I'm going to give it this curious little formula. Looks like this. There we go. And I'm just quickly going to set up different print statements here to capture what's going on. Now, if I send it a message like this, you can see that the second and third outlets here receive the output of pits and pits ordinario. So to test that, if I send it something like ord or ordinario by itself without any pits involved, you can see here that this particular string is sent through the unmatched outlet. So there's no instance of pits. In other words, what this is doing is it's finding any instance of pits inside a string. So a playing style that contains the word pits will be matched here. Okay, with that brief little example in mind, let's set up a test here so that all the playing styles, all 188 of them, get filtered through a system and only certain ones are allowed to pass through. let's create a trigger object with 2 bangs and the full list of 188 things. And then we'll iter through those things one at a time. We'll copy the list, and I'm just going to clone this object, put it right there, and create a little gate here with 2 outlets, the first of which is open. And I'll send each of those individual items through the gate. And in this case, I'm going to use the 3rd outlet, and I'm going to tell the gate to send the data through outlet 2 if the word pits is matched. This is going to be outlet 2 of the gate object right here. So in other words, we'll be collecting all of the styles that pass the test and group them together. Now here in the unmatched outlet, we could trigger the message 1 and have all the playing styles that fail the test, which is essentially everything we want, sent through the first outlet of gate. However, I want to check for more than one condition. So why don't we go ahead and just highlight and duplicate or clone this and send the unmatched output into another regular expressions object, but this time I'm gonna change this to Lenyo. So we'll be testing for 2 different things. And the idea here is if there's any unmatched left, we can send it to gate output number 1. And using grouping objects, we'll collect all of the things that fail the test, everything but the pits and legato playing styles. And out of this outlet, we'll capture all of the styles that pass the test. Those are the things we want to take out of the final list there. The bangs will, of course, trigger the output of these ZL group objects. And just to make sure we know what we're doing, okay, so I'll print this one as removed items, and I'll prepend this list of things we want with the styles message like this. And also, I'm going to duplicate our length tester here as well. And this will become the remaining styles after filtering. And it's this list that we want to send out. Now let's go ahead and clear this and run the test one more time. And as you can see, we have 188 styles in total. 182 of them made it through. And the ones that didn't make it through are right up here. 1, 2, 3, 4, 5, and 6 different styles were removed, which is consistent with the difference between these 2 numbers. So we've just used regular expressions to remove some of the things that we don't want. And now we can rerun our orchestration, confident that none of those particular styles will be included in our solutions. Now actually, why don't we set up a little system here to play both the target and the solution back at the same time. I'm going to create a play message, and I'm going to create a stop message. Now the play message can go right here into the first inlet of Bach roll. It cannot, however, go into the play object to trigger the output of the target sound. Instead, let's trigger another message, start. This is a little bit weird, but this is how we're going to get both of these things to trigger playback at the same time. Stop, however, can be sent to both the Bach roll and our play object. Why don't we pull the target volume down just a little bit? Try that one more time. Okay, sounds pretty good to me. However, the keen observer might have noticed the sound in the target has a bit of silence somewhere in here. And so why don't we alter the length of these notes using some simple Bach syntax. So notice that these are the longest notes in my entire sequence. I'm going to select notes based on a condition using Bach syntax here. In a message, I'll say cell note if some amount. And if I just click on any of these long notes, I can see their duration here. 2,647 milliseconds, somewhere around there, more or less. So how about this? I'm going to say 2,600 here. And if I click that, I can select almost all of those notes that are kind of in that middle spot right there. I'm going to create another message here that says duration 0.5 times. In other words, I'm going to take the selected, highlighted in purple notes, and then cut them in half. Let's see here. I'll do it one more time actually to make it kind of extra short. And for the last duration here, these are all going to be kind of around the same length. Almost 1300 or so milliseconds. So I'll do the same thing here. This will be the first series, and then this will be the second series of long notes. And this one I'll just say 1300. And I'll start from nothing. Click the button there, and you can see I've selected more or less all of the notes in the final duration. And I'll also cut those in half. That's a result that I'm happier with. And in the Max version, we have the Bach tools available to us to do things like quickly get in there and edit things like note durations. We can move this stuff around with a lot of flexibility. We can transform the notation in a lot of ways before we export it to XML or save the work. So that was a long haul, and that's it for this video. Hope you've enjoyed today's tutorial. In the next video, I'm going to show you how to further refine these sort of complex sounds in the middle of the sound target using another method. So hope you'll join us then. Have a great day, and see you in the next video.